Alright, let's begin with question 16. Okay, first we get some information. After hitting a wall, a ball decelerates at 2.5 meters per second square. So we know decelerate at 2.5 meter per second square, right? Means we draw the VT graph, it will look something like this later. Then yeah, should be constant if the question doesn't mention. So anyways, let's use our highlighter. Then we find that we just highlight the information we get. Decelerates at, comes to rest. Okay, this one is important. Let's underline to rest. Decelerates. Then they'll ask what is the speed of the ball as it hit the wall. So as it hit the wall, it implies that we are looking for the initial velocity or speed . In physics, we usually label this as U, at least for O-level physics or whatever other country's equivalent . Alright, so firstly, we use our best friend. In kinematics, we draw a VT graph. Okay, just follow along. VT, V being velocity if you're not sure. Anyways, we just draw it like this. I think it's pretty simple, like decelerates constantly. This is not constant, so let's redraw that a little. Okay, 1 second. Alright, we know that in a velocity time graph, the area under graph is actually the distance traveled. And it says it comes to rest in 85 cm, except that for this one, we need to change to 0.85 meters because cm is not the SI unit for distance. Alright, so now that we have that, we know that the ball decelerates at 2.5 meters per second square. So using the equation, acceleration equals to final velocity minus initial velocity over time, we can sub in that A is negative 2.5, the final velocity is 0 as it comes to stop, and U should be, we just leave it as U because that's what we're looking for. And then T, we just leave it as T. So from this, we actually find out that the initial velocity is 2.5 T. Or alternatively, we can say that T is, let's do the math, 1 over 2.5 U. Therefore, T is 0.4 U. So we can label 0.4 U, and then this one will just be U. So we know that this entire area under graph will be the distance. So we can take half times U times 0.4 U equals to the distance traveled, 0.85 meters. Remember, must convert from cm. We get 0.2 U square equals to 0.85 meters. Therefore, U square will be 0.85 over 0.2. Therefore, U would be 0.85 over 0.2. If you just press your calculator, you would get, give me a second here, you will get 2.06 meter per second. Okay, this is the final answer, like this. It's just like that. Pretty straightforward question, but there are many ways you can go wrong, so you just need to practice to make sure you don't screw up . Okay, that's the end for question 16.